Welcome back to Arxflix. Today, we're exploring a fascinating new paper titled Self-Play Fine-Tuning Converts Weak Language Models to Strong Language Models. This research tackles the challenge of improving a large language model, LLM, without needing additional human annotated data. Traditional methods for aligning LLMs with desired behaviors, like supervised fine-tuning, SFT, and reinforcement learning from human feedback, RLHF, heavily rely on human annotated data. This can be expensive and time-consuming. This paper introduces a novel fine-tuning method called self-play fine-tuning, SPIN. SPIN leverages a self-play mechanism, where the LLM plays against itself to improve its performance. Here's a visual representation of the SPIN algorithm. It starts with a supervised fine-tuned model and iteratively generates synthetic data by having the model respond to prompts from the SFT dataset. SPIN operates in two steps: training the main player and updating the opponent player. The main player is a function that aims to distinguish between responses generated by the LLM and those generated by humans. The opponent player is the LLM from the previous iteration. The main player is trained to maximize the expected value gap between the target data distribution and the opponent player's distribution. This is achieved by using a logistic loss function, which helps prevent the excessive growth of the function's values. The opponent player is updated by maximizing the expected value of the main player's function, ensuring that the LLM generates responses that are indistinguishable from the human-generated responses. The paper provides a theoretical analysis of SPIN, proving that the global optimum of the training objective is achieved only when the LLM's distribution aligns with the target data distribution. The researchers evaluated SPIN on various benchmarks, including the Hugging Face OpenLLM Leaderboard, Montana Bench, and datasets from Big Bench. Here's a graph showing the average score of SPIN across different iterations on the Hugging Face OpenLLM Leaderboard. As you can see, SPIN consistently improves the model's performance over successive iterations. This figure compares SPIN's performance with DPO training. SPIN, even without using new data, achieves comparable performance to DPO at iteration 0 and surpasses it at iteration 1. The researchers conducted ablation studies to investigate the impact of training size and iterative training. This graph shows the scaling effect of training size for SPIN compared to SFT. SPIN demonstrates significant improvement with increasing training sizes, while SFT shows limited gains after the first epoch. This figure illustrates the training dynamics of SPIN over multiple epochs. It highlights that iterative training is crucial, as extending training within a single iteration reaches a limit and cannot surpass the performance achieved in the next iteration. SPIN is a promising new approach for improving LLMs without requiring additional human data. It leverages a self-play mechanism to iteratively enhance the model's performance, achieving results comparable to or even exceeding those of models trained with extra human data or AI feedback. This research opens up exciting possibilities for developing more efficient and effective methods for aligning LLMs with desired behaviors. Thanks for watching Arxflix. Don't forget to like, subscribe, and share this video with your fellow AI researchers. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.